Okay, hi everyone, welcome back to this video series on data centers. Practice example hash 6c255.255.255.252/30. Just one more. 192.168.10.0 equals network address 255.255.255.252 equals subnet. Subnet question mark 4 host 2 valid subnet 0, 4, 8, 12 etc. all the way to 252. Broadcast address for each subnet, always the number right before the next subnet. Valid hosts, the numbers between the subnet number and the broadcast address. The following table shows you the subnet, valid host and broadcast address of the first 4 and last 4 subnets in the 255.255.255.252 Class C subnet. Subnet 0, 4, 8, 12, 240, 244, 248, 252. First host 1, 5, 9, 13, 241, 245, 249, 253. Local host 2, 6, 10, 14, 242, 246, 250, 254. Broadcast 3, 7, 11, 15, 243, 247, 251, 255. Subnetting in your head Class C address. It really is possible to subnet in your head. Even if you don't believe me, I'll show you how, and it's not all that hard either. Take the following example: 192.168.10.33 equals node address 255.255.255.224 equals subnet mask. First determine the subnet and broadcast address of the above address. You can do this by answering question 3 of the big 5 questions. 256 minus 224 equals 32, 0, 32, 64 and so on. The address of 33 falls between the two subnets of 32 and 64 and must be part of the 192.168.10.32 subnet. The next subnet is 64, so the broadcast address of the 32 subnet is 63. Remember that the broadcast address of a subnet is always the number right before the next subnet. The valid host range is 33 minus 62, the numbers between the subnet and broadcast address. Okay, let's try another one. We'll subnet another Class C address. 192.168.10.33 equals node address 255.255.255.240 equals subnet mask. What subnet and broadcast address is the above IP address a member of? 256 minus 240 equals 16, 0, 16, 32, 48 and so on. The host address is between the 32 and 48 subnets. The subnet is 192.168.10.32 and the broadcast address is 47. The next subnet is 48. The valid host range is 33 minus 46. The numbers between the subnet number and the broadcast address, we need to do more just to make sure you have this down. You have a node address of 192.168.10.174 with a mask of 255.255.255.240. What is the valid host range? The mask is 240, so we'd do a 256 minus 240 equals 16. This is our block size. Just keep adding 16 until we pass the host address of 174 starting at 0. Of course, 0, 16, 32, 48, 64, 80, 96, 112, 128, 114, 160, 176 and so on. The host address of 174 is between 160 and 176, so the subnet is 160, the broadcast address is 175. The valid host range is 161 minus 174. That was a tough one. One more is the easiest one of all Class C subnetting. 192.168.10.17 equals node address 255.255.255.252 equals subnet mask. What subnet and broadcast address is the above IP address a member of 256 minus 252 equals 4. Always start at 0 unless told otherwise. 4, 8, 12, 16, 20 and so on. You've got it. The host address is between the 16 and 20 subnets. The subnet is 192.168.10.16 and the broadcast address is 19. The valid host range is 17 minus 18. Now that you're all over Class C subnetting, let's move on to Class B subnetting. But before we go, let's have a quick review. What do we know? Okay, here you can really apply what you've learned so far and begin committing it all to memory. This is a very cool section and I've been using in my class for years. It will really help you nail down subnetting. When you use a subnet mask or slash notation CIDR, you should know the following. /25, what do we know about a /25? 128-bit mask, 1 bit on, 7 bits off. 1 0 0 0 0 0 0 0. Block size of 128, 2 subnets each with 126 hosts. /26. What do we know about a /26? 192 mask, 2 bits on, 6 bits off. 1 1 0 0 0 0 0 0. Block size is 64, 4 subnets each with 62 hosts. /27. What do we know about a /27? 224 mask, 32 bits on, 5 bits off. 1 1 1 0 0 0 0 0. Block size of 32, 8 subnets each with 30 hosts. /28. What do we know about /28? 240 mask, 4 bits on, 4 bits off. Block size of 16, 16 subnets each with 14 hosts. /29. What do we know about a /29? A 248 mask, 5 bits on, 3 bits off. Block size of 8, 32 subnets each with 6 hosts. /30. What do we know about a /30? 252 mask, 6 bits on, 2 bits off. Block size of 4, 64 subnets each with 2 hosts. Regardless of whether you have a Class A, Class B, Class C address, the /30 will provide you with only 2 hosts. The mask is suited almost exclusively, as well as suggested by Cisco, for the use on point-to-point links. If you can memorize this what do we know section, you'll be much better off in your day-to-day job, in your studies. Try saying it out loud, which helps you memorize things. Yes, your significant other and or clockwise will think you've lost it, but they probably already do. If you are in the networking field, and if you're not yet in the networking field but are studying all this to break into, you might as well have people start thinking you're an odd bird now, since you'll eventually anyway. Subnetting Class B addresses. Before we dive into this, let's look at a possible Class C subnet masks first. Notice that we have a lot more possible subnet masks than we do with a Class C network address. 255.255.0.0/16, 255.255.128.0/17, 255.255.192.0/18, 255.255.224.0/19, 225.225.240.0/20, 255.255.248.0/21, 255.255.252.0/22, 255.255.254.0/23, 255.255.255.0/24, 255.255.255.128/25, 255.255.255.192/26, 255.255.255.224/27, 255.255.255.240/28, 255.255.255.248/29, 255.255.255.252/30, We know the Class B network address has 16 bits available for host addressing. This means we can use up to 16 bits for subnetting because we have to have at least 2 bits for host addressing. Using a /16 means you are not subnetting with a Class B, but it is a mask you can use. Subnetting practice examples: Class B addresses. The following sections will give you an opportunity to practice subnetting Class B addresses. Again, I have no mention that this is the same as subnetting Class C, except we start in the third octet with the exact same numbers. Practice example /1B255.255.128.0/17. 172.16.0.0 equals network address. 255.255.128.0 equals subnet mask. Subnets 21 equals 2, same as Class C. Host 215.-2 equals 32. 766, 7 bits on in the third octet and 8 in the fourth. Valid subnets 256 minus 128 equals 128.0.128. Remember that subnetting is performed in the third octet, so the numbers are really 0, 0 and 128.0 as shown in the next table. These are the exact numbers we use with Class C. We use them in the third octet and add a 0 in the fourth octet for the network address. Broadcast address for each subnet. Valid host. The following table shows the 2 subnets available, the valid host range and the broadcast address. Subnet 0.0, 128.0, first host 0.1, 128.1, last host 127.254, 255.254, broadcast 127.255, 255.255. Okay, notice that we just added the fourth octet's lowest and highest values and we came up with the answer. And again, it's done exactly the same way for a Class C subnet. We just used the same numbers in the third octet and added a 0 and 255 in the fourth octet. Pretty simple, huh? I really can't say this enough. It's just not hard. The numbers never change. We just use them in different octets. Practice example 2B 255.255.192.0/18. 172.16.0.0 equals network address. 255.255.192.0 subnet mask. Subnets 22 equals 4. Host 214-2 equals 116.382. 16 bits in the third octet and 8 in the fourth. Valid subnets 256 minus 92 equals 64.064, 128, 192. Remember that the subnetting is performed in the third octet, so the subnet numbers are really 0.0, 64.0, 128.0 and 192.0 as shown in the next table. Broadcast address for each subnet. Valid host. The following table shows the 4 subnets available, the valid host range and the broadcast address of each subnet. 0.0, 64.0, 128.0, 192.0 first host. 01, 64.1, 128.1, 192.1 last host. 64.254, 127.254, 191.254, 255.254, broadcast 63.255, 127.255, 191.255, 255.255. And again, it's pretty much the same as it is for a Class C subnet. We just added 0 and 255 in the fourth octet for each subnet in the third octet. Practice example 3B 255.255.240.0/20. 172.16.0.0 equals network address. 255.255.240.0 equals subnet mask. Subnets 24 equals 16 hosts, 212 minus 2, 40, 94 valid subnets. 256 minus 240 equals 16, 0, 16, 32, 48, etc. up to 240. Notice that these are in the same numbers as a class C. 240, we just put them in the third octet and add a 0, and 255 in the fourth octet. Broadcast address for each. The following table shows the first four subnets, valid hosts and broadcast addresses in a class B 255.255.240.0 mask. Subnet 0.0, 16.0, 32.0, 48.0, first host 0, 1, 16, 0, 1, 32, 0, 1, 48, 0, 1, last host 15.254, 31.254, 47.254, 63.254, broadcast address 15.255, 31.255, 47.255, 63.255. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.